Right, this is just a quick video going through some of the homework that we did. Starting off with exercise 1.2 question number 16. This is a straightforward difference of two squares. Whenever you've got something with a plus and a minus in there and they've got the same value on the outside, that means that this one here can just be written as you multiply the first two together, then you multiply the last two together. Positive with a negative means you're going to get a negative, and then just squaring that you get 9 over x squared. So this is actually the difference of two squares. This one here is exactly the same. Remember, you don't, on these ones here, you don't get a middle term because it cancels out. If you had this one with this and that one back over there, they cancel out. Okay, this one over here, we're going to get the same. We're not going to get a middle term because you've got opposite signs and you've got the same thing on the ends. Right, therefore this one here is just cos squared x minus 1. This one over here, remember when you're actually multiplying the same base but with different powers, you just add the powers. So this one here is just e to the 2x plus e to the 4x. Right, on to the next one. When you have multiple terms inside a bracket, you just do it term by term. So the first thing that you do, this is actually this whole bracket repeated, so that's that whole bracket repeated. So all I'm going to do is I'm just going to go, hang on, if I just go to my eraser, just rub that bit out. All I'm going to do first is I'm just going to multiply 4bc to each of these terms. That will give me 16b squared c squared minus 8ab squared c plus 12a b c squared. Then I'll do the next one, which is the minus 2ab, which would then get me a minus 8a b squared c, and then a plus 4a squared b squared, and then a minus 6a squared bc. Then multiply the last one, which is a 3ac, would get me 12abc squared minus 6a squared bc plus 9a squared c squared. Then all you got to do is just get all of the common terms together, which I'll leave that to you. I mean, you just go through and just simplify by putting the terms together. Now this is in factorizing. We're looking for a common factor, and this one here, obviously sin x comes out the front because that is common, and you're just left with cos x plus 1. This one over here, you've got an a as common. There's several ways to do this, but let's just take out a to a half. That leaves me with 1 plus a. Right, now I'm going to have something up here, so when I'm actually multiplying it, I know I have to add exponents. So the only way I can add that exponent is a minus 1, because minus 1 plus a half will give me a minus a half. Right, this here, question 9 on 1.5 is actually something called two-stage factorizing. You factorize the first, then you factorize again twice. On this one here, we've got a common factor of 3, and it left with x minus y, plus we've got a common factor of a, and I'm left with y minus x. Now these two terms are almost the same. However, what I could then do is rewrite this as a minus a. If I took out a minus 1, I would have had the same thing in both of the brackets. So then if I take those out the front, I'm left with a 3 minus a. So basically what it is, it's factorizing. They're making sure that the things in the brackets are the same, then factorizing again. So it's two-stage factorizing. This is another example of one. What you do is you've got to get something which is common in each of these. So the first thing that we're going to do is we're going to put some things together that actually do have some common things. The first two terms don't have anything in common, but the first and the third term do. So you'd put 2px plus qx, and then you'd go minus 5qy minus 10py. Then we can start looking for things that are actually in common now. So we've got an x on both of those, so we'll take that out and left with 2p plus q. Right, we've got a minus and 5 will be in both of those, and I could take out a y as well. So if I take out minus 5y, I'm going to be, oops, put the bracket around the wrong way. I'm going to be left with a q plus a 2p, which these two brackets are exactly the same. Doesn't matter which order they're in because it's addition. Right, so therefore I can take that up the front, 2p plus q, and I'm left with x minus 5y. So I factorised, first I got the things together, then I factorised, and factorise again, two-stage factorising. This question here, 1.69, is very common, where it's actually a quadratic. It just doesn't look like that. You've got an e to the x term, and you've got an e to the x squared term. So another way of writing that could have been a squared plus 8 e to the x plus 12. Then it's just a basic quadratic equation. Remember, when you've got two exponents beside each other, that actually means that they're multiplied. Right. If I then factorise this, this is going to be two numbers that add to this, that multiply to that, is going to be 6 and a 2, plus 6 e to the x plus 2. Done. This is exactly the same, it's just a straightforward quadratic. Again, two numbers that add to minus 8, that multiply to minus 20, so I've got a cos x, this would then be minus 10, and a cos x plus 2. Right, going down. These ones are again factorising. First thing you always look for, is there a common factor? And in this one, yes there is. It's x into x squared minus 1. Then you've got a difference of two squares. Difference of two squares always means square root the first, and then square root the second. Square root of 1 is just 1. So, and you always have opposite signs in the brackets. Right. This one here, again, it's purely difference of two squares. So you've got a squared term in the front minus a squared term on the end. So this is just 1 over sine alpha plus 1 over cos alpha times by 1 over sine alpha minus 1 over cos alpha. Right. This one here, again, what you've actually got is you could actually do the difference of two squares, and you could go that way. You could say that this is actually x cubed all squared minus y cubed all squared, and then it's just going to be x cubed plus y cubed into x cubed minus y cubed. Right, and again in that chapter itself it shows you how to actually go about expanding when you've got an x cubed plus y cubed and an x cubed minus y cubed. Different ways of doing that, but that's where it starts off with. Right, 2.5 is actually getting into composite functions. And basically what that means is, for example, if you have a function like 2x, and you have another function like x squared plus 1. So basically what you do is you put it in, we'll call that one a circle, we'll call that one a square, and then we start off with an x. So basically what you do is you can do this in either way. You can start off with the x, then you can put it into the square, then you can put it into the circle. If you started off with the x and if you put it into the square first, you would have got x squared plus 1. Then if you'd have put that into the circle, that whole thing there goes into the circle. So in other words, everything in there is doubled. So that would be 2 into x squared plus 1. If we're going the other way around, if we started off with an x, went to a circle and then a square, first thing we'd do is circle. If you put it into the circle, you would double it. Then you put it into the square. Putting it into the square means wherever you see an x, you stick the 2x. So you'd have a 2x squared plus 1, which would be 4x squared plus 1. Okay, so that's basically how composite functions work. First you do the first function, then you do the second function. So when it's actually saying f of x equals x plus 1 and g of x equals 2x minus 1, so you've got that f equals x plus 1, and you've got that g equals 2x minus 1, and it wants f of g of 3. So all it's saying is put 3 into g first, so it just wants g of 3, and get out a number. So that just means 2 times 3 minus 1, which is just 5. Then put that number in for f. So you want 5 into the f. So this is just, wherever you see the x, you stick the 5. 5 plus 1, 6. Right. Question 7 is basically asking for the different kinds of formulas that you get out. I'm actually running out of room. How much can I go sideways? This is cool. Right, question 7. Okay, A. F of g of x. So in other words, I start off with g of x, which is x squared, and I stick it into f. So I got 2. Wherever I see an x, I stick the g. X squared plus 5. B. Now I start off with f, and then I stick it into x. So f is 2x plus 5. Then when I stick that into g, I just square it. C. H g of x. So I start off with g of x first, and then I put it into h, which is 3, and it's going to give me x squared, because that's the g bit, minus 2. Right, I think you're getting the hang of that. Right, 2.7. These ones here, basically what you're trying to do is you're trying to make the denominator up on the top. And there's reasons why we're doing that. We're actually going to be using that a lot when we start doing integration. But anyway, we're trying to get the bottom line up the top. So the way that we do this is we just put the bottom line up the top. And this is still all over x plus 1. You force it up there. And then you look back and say, look, I'm going to need a 3x out of that, so you've got to put a 3 in the front. Then you go backwards and go, well, at 3 times 1, that's going to give me a plus 3. I want a minus 5. So therefore, I'm going to have to subtract something over here to get me a minus 5. So if I put minus 8 there, if I expanded that, those will all be exactly the same. Because that'll give me 3x, the 3x, plus 3 minus 8 gives me the minus 5. So this then equals, if I actually look at this, this is 3 over x plus 1, all over x plus 1, minus 8 over x plus 1. Because remember, whenever you've got fractions up the top, like if I have something like 2 plus 3 all over 5, I can write that as 2 over 5 plus 3 over 5. So remember, you can always separate it into separate fractions. Now in this case here, they then cancel, and you're just left with a number, minus 8 over x plus 1. Right, the next one's even easier because it actually doesn't have a number in the front. So what we're going to do here is we're going to force an x minus 3 on the top. We've already got an x minus 3 on the bottom. Now, but I actually want plus 2, so I'm actually going to have to add something. I have to add plus 5 to get me the 2 back. And then again, I can separate this, separate my numerators, for x minus 3 plus 5 over x minus 3. Now remember, whenever you've got a same number on the top and the bottom, they are exactly the same. It's like 3 over 3, that just equals 1. So if I've got x minus 3 over x minus 3, that's just 1 plus 5 over x minus 3. This one over here, again, I've got the same on the top and the bottom, so I'm going to force the top to be an x plus 2. The bottom stayed an x plus 2. Then I need something up the top to get back to 0, so I've got a minus 2. This will leave me with 1 minus 2 over x plus 2. I just sort of skipped a step there. Right, those are the first part, and the second part I'll make a different video for.